Hi everybody, today we're going to talk about standard form for linear equations. This is our first topic in Unit 5. So our Unit 5 is about linear equations or linear functions. A linear equation is just an equation that forms a line when you graph it. So we've actually been talking about linear equations and linear functions over the course of the past 2 units. Anytime you have an equation that would make a line when you graph it, that's called a linear equation or a linear function. So there's one form of the equation of a linear function that we've already talked about, and that was slope-intercept form. And if you recall, slope-intercept form was y equals mx plus b, where m is the slope and b is the y-intercept. There are 2 other forms of the equation of lines that we're going to talk about in this unit. The first one is going to be standard form. Standard form is most often used when we start with a word problem, so that's what we're going to try first. Jake goes to the store. He buys X cans of soup and Y cans of tomato. Soup costs $3 per can and the tomato costs $2 per can. He only has $12 to spend. So we're going to write an equation modeling how many of each he can buy. So our equation is going to start with, let's start with the soup. He's going to buy X cans of soup and they each cost $3. So we would have 3X. Then he's going to buy Y cans of soup and they each cost $2. So we're going to add on to that to Y. And he has $12 to spend. So that can equal $12. This is an example of an equation in standard form. It looks very different from slope-intercept form, y equals mx plus b. So we're going to spend some time talking about this form. You have seen this form before, mostly when we were solving for x and y intercepts. We saw equations in this form. So standard form looks like this: ax plus by equals c. And there are some rules about how we can write this. There are rules because we want everybody's standard form equation to look the same. So these rules will limit what we can have in our standard form, so that if I write the standard form of the equation and you write it, it will look the same. So here are the rules. A and B cannot both be 0. If you look at A, B, and C, A and B are the coefficients in front of x and y. If both of those were zeros, then this whole side of the equation would be 0, and we'd have 0 equals some number, which wouldn't be impossible. So A and B can't both be 0. A, B, and C must be integers. Integers are positive and negative whole numbers and 0. So A, B, and C must be whole numbers or negative whole numbers, or they can be 0. So in other words, you cannot have fractions or decimals as your numbers for A, B, and C. A, B, and C have a greatest common factor that is 1. That means that the numbers A, B, and C can't have a common factor other than 1. For example, if all of them were divisible by 5, then it would not be in standard form. So you can't have a number you could divide all 3 of these by, other than 1. And finally, A must be positive. So the value of A can be 0, as long as B is not also 0, or anything positive. We don't want this number to be negative. And again, the reason for these rules is just so that when I write the standard form and you write it, they match. All right, so we're going to look at several equations, and we're going to decide if they are in standard form or not, and if they're not, we're going to try to fix the problem. Okay, so looking at this first equation, we first need to check, is it in the right format? So is it in the format ax plus by equals c? And it does look like it's in that, taking on that form. Ax, by, c, looks pretty good. So now let's check the 4 rules. First of all, A and B cannot both be 0, and they're not. One is A is B, and A is 6 and B is 10. Secondly, A, B, and C all have to be integers. And they are 6, 10, and 14. They're all integers. Third rule, A, B, and C cannot have a GCF other than 1. All numbers have a GCF of 1. What that means is, when I look at these three numbers, there shouldn't be anything other than 1 that I can divide all three of them by. And in this case, there is a number I can divide all three of them by. I can divide all three of these numbers by 2. So is this equation in standard form? No, because of that fact, because I could divide them all by 2. However, I can fix that problem, as I have already started to do. If I actually divide them all by 2, I'll end up with 3x plus 5y equals 7. And I'm allowed to do that because of the division property of equality. I'm allowed to divide the whole equation by 2. And now I have a new equation. It's the same, it's equivalent to the first equation, but now there's no GCF. And since it's following all the other rules, including that A is positive, then this is now in standard form. So this equation is fine in standard form. Okay, let's look at another one. So again, we're first checking to see, is it in the right format? AX plus BY equals C. Sometimes students say, wait, it's minus B here. Well, that's okay. B is allowed to be negative. A is not supposed to be negative, but B can be negative. So that's fine that this number is a negative 6. So that's not a problem. All right, so let's check the other rules. A and B are not both 0. One's 4 and one's negative 6. A, B, and C are all integers. 4 is an integer, negative 6 is an integer, and 15 is an integer. A, B, and C cannot have a GCF other than 1. So I have to see, is there any number I can divide all of these by? Well, some people might think 2 again. I can divide 4 by 2. I can divide 6 by 2. But I can't divide 15 by 2 evenly. So there is no common factor for 4, 6, and 15 other than 1. And finally, A cannot be negative, and it's not. So is this in standard form? Yes. Okay, next one. Again, we want to start by seeing is it in the right format. AX plus BY equals C. So my A value here is 2/3. My B value, even though we didn't write it, is a 1. And my C value is 4. So it is in the right format. Let's check the rules. A and B can't both be 0. Okay, they're definitely not. A, B, and C have to be integers. This is a problem. One of these is not an integer. The number that's not an integer here is 2/3. It's a fraction. So that is not in standard form. So now I'm going to try to fix that problem. So I need to somehow make this not a fraction anymore. So sometimes students will say, can I multiply by the reciprocal? Well, I could do that, and that would help me because these would cancel, and I would be left with 1x. The problem is, as you might recall from when we were solving equations, if I multiply one thing in the equation by 3/2, I have to multiply the entire equation by 3/2. That line. And if I multiply the entire equation by 3/2, then I have a problem because I'm going to actually make the coefficient in front of y into a fraction. It would be 3/2 y. And so I didn't solve the problem by doing that. So instead of multiplying by 3/2, I'm just going to multiply by 3. So if I multiply everything by 3, this won't be a 1. What good will that do? Well, 2/3 times 3, the 3's cancel out, leaving me with just 2x. So no longer a fraction. Then I can do 3 times 1y is 3y. And I can't forget to also do 3 times 4 is 12. So because of the multiplication property of equality, I multiply the whole equation by 3. It's still equivalent. And now I don't have any fractions. So let's just make sure it follows all the other rules. A and B are not both 0. A, B, and C are all integers now. A, B, and C do not all have a common factor. Even though 2 and 12 can both be divided by 2, and 3 and 12 can both be divided by 3, there's no number that all 3 of them can be divided by. So that's good. And A is not a negative number. So this is in standard form. Okay? This one, let's see. First we want to check, is it in the right format? AX plus BY equals C. Actually, this one's not in that format. You can see we've got 3y, but we don't have our AX on this side. Our AX is actually on the other side of the equal sign with the C, which is 4. So what I want to do is I want to get this 2x over to this side so it'll be in the right spot. So if you think back to your equation solving strategies, and specifically literal equations, to move that 2x, what I need to do is I need to subtract 2x from both sides. So the 2x will cancel on the right side, leaving me with just equals 4. So there's my equals C. And on this side, I want to have AX plus BY. So I'm going to put my AX term, which is now negative 2x, and my 3y on this side. So initially, was this in standard form? No, this equation was far from standard form. Now we're much closer because we at least have the right format. So let's check the rules. A and B cannot both be 0. They're not. A, B, and C must all be integers, and they are. A, B, and C cannot have a common factor. Negative 2, 3, and 4. There's nothing I can divide all 3 of those by, so that's fine. And finally, A cannot be negative. Uh-oh. The A value here is negative. So that has to be fixed as well. So to change something from negative to positive, there's a couple ways I could do that. I could multiply the whole equation by negative 1, which would change a negative 2 to a positive 2. Or I could divide everything by negative 1, which is what I'm going to do. So if I want to multiply or divide by something, I have to do it to the whole equation. So negative 2 divided by negative 1 is positive 2. 3 divided by negative 1 is negative 3. And 4 divided by negative 1 is negative 4. And now it follows all the rules, so now it's in standard form. Okay, this one, let's see. Lots of problems here. Okay, first of all, it's not in the right format. So we're going to have to move things around. Second of all, it's got fractions. So that's going to be a problem too. So is this in standard form? No. What I would like to do first is deal with the fractions first. So I want to get rid of those fractions so I don't have to work with fractions throughout the whole time. So how can I get rid of these fractions? Well, one is a denominator of 5, the other is a denominator of 3. If I want to wipe out both of those at once, just like we did with equation solving, I can multiply by the least common denominator, which is 15. I have to remember to multiply everything by 15. So 15y equals 15 times 4/5 is 12. And 15 times 7/3 is 35. Okay, so that's better. At least I don't have fractions now. But again, it's not in this format, ax plus by equals c. If you'd like to at this point, you could pause the video and try on your own, see if you can get it into the right format, or you can continue to follow along. So what I need to do again is move this x term over to that side. So just like I did last time, to do that, I'm going to subtract it from both sides. So I'm going to subtract 12x, subtract 12x. So the 12x's will cancel. Over on this side, again, I want to start with my ax term, so I'm going to put negative 12x, since it was being subtracted, plus 15y equals, and over here I'm left with negative 35. Okay, so now I have the right format. A and B are not both negative. A, B, and C are all integers, no fractions. A, B, and C do not have a common factor, but A is negative. So I have to fix that problem. So I can fix that, again, by dividing everything by negative 1. So the final answer in standard form is 12x minus 15y equals positive 35. And now this is in standard form. Okay, let's check this one. Ax plus by equals c. It is in the correct format. A, B, and C are all integers. A and B are not both 0. A, B, and C do not have any common factors. and A is a positive. So this is already in standard form. This one, as you can imagine, is clearly not in standard form. See if you can figure out what's wrong with it. Now, if you'd like to, you can try to pause the video and try to fix it yourself. All right, here's what we could do. It's got a lot of fractions. So to get rid of the fractions, I'm going to multiply by the least common denominator, which is 12. That would give me 8x minus 9y equals 5. So it was not in standard form, but I was able to convert it. Now it is. This is standard form. And our last one, y equals negative 5. Is this in standard form? Okay, well, let's think. It's supposed to be ax plus by equals c. There is no x term. That means it's like 0x. Now the y, even though I didn't write it, is 1y, and the c is negative 5. So let's check it. A and B cannot both be 0. Well, A is 0, but B is 1, so that's okay. A, B, and C have to be integers. 0, 1, and negative 5 are all integers. They can't have a common factor. Well, there's nothing I can divide all these by. And A has to be non-negative, and A is 0, and that's okay. So this equation, y equals negative 5, is in standard form. I don't have to convert it at all. That equation is already in standard form. So this concludes what we're going to do with the video. Hopefully you have an understanding now of what it means to be in standard form. And we'll discuss this more in class. Make sure you bring your notes with you.